Okay, so for lesson 18, there's not really notes and all that. There's just an assignment in Math Excel. But part of the assignment is word problems, and I know that word problems can be tricky. So I thought I would make a quick little video walking you through the word problems. Now, my word problems are going to be different than yours, so you are going to have to apply what I do in the examples to your own problems, but hopefully this should help. Now, you may need this video and you may not. If you can work through the word problems on your own without watching the video, that's fine. But this video can be a good resource if you get stuck or you don't really know how to start. So, we'll start with problem number 8 and we'll just go from there. Okay, so the average apartment rent in country A is $1,300 per month. Jacob has an apartment in city B and one in city C. The total monthly rent for the two apartments is $4,789. The rent in city B is $1,129 less than rent in city C. Find the rent for each apartment. So the first thing that we need to do is we need to pull out the important information. Now, the first sentence here is deceiving. The average apartment rent in country A is $1,300 per month. We don't really need that information because we're talking about Jacob's apartment. Jacob has an apartment in city B and one in city C. We know the total monthly rent is $4,789, and we know that city B is less than city C by $1,129. So let's use that information to set up a system of equations. So the first thing we need to do is to define our variables. So I'm going to say that B represents the apartment in city B because that makes sense to me. I'm going to say that C represents the apartment in city C, again, because that makes sense to me. We know the total rent for the two apartments is $4,789. So, and I guess I should say rent for those apartments. All right, so if we add the rent from apartment B and apartment C, we should have a total of $4,789. All right, so that's our first equation. Then the city B is $1,129 less than city C. So B is, if it's less than, we turn it around. So C minus 1,129. Okay? Okay. So now that we have it set up, I'm not going to work out the whole thing for you, but if you think about our different methods for solving systems, we have graphing, substitution, and elimination. So substitution is best when you have one of the variables already solved for. So in this case, B is already solved, or this equation is already solved for B, I should say. So you can take this quantity, plug it in for B, and solve using substitution. So I'll make a little note, solve with substitution. Okay, now, like I said, I'm not going to walk you through that because you've practiced substitution already, but we do have the system set up and ready to go. All right, now let's look at question 9. During a 1-month promotional campaign, Friends Fix gave either a free DVD rental or a 12-serving box of microwave popcorn to new members. It cost the store $1 for each free rental and $2 for each box of popcorn. In all, 45 new members were signed up, and the store's cost for the incentive was $79. How many of each incentive were given away? So if we think about what we're talking about and what we're comparing, we're talking about money, and we're talking about free rentals and popcorn, okay, and new members. So let's pick out the important information here. We know that we're going to need free rentals and popcorn. Those are going to be our variables, okay? We have money, we have $1, $2, and $79, and then we have 45 new members, which is what's represented by the free rentals and the popcorn because each new member gets one or the other, okay? So, again, let's set up the system. So I'm going to say that R represents the free rentals, and P represents popcorn. Okay, and we know that both of those are really representing new members that are signing up. Okay, so how many members did we have total? 45. So if we add up the number of rentals plus the number of popcorn boxes that we gave away, it should equal 45. Okay, now how much did each rental cost? $1. So 1R plus, or you could just leave it R, but just for visual purposes, 1R, and then $2 for each popcorn, so 2P, equals how much did they spend altogether? $79. Okay, so here you have another system set up. If you remove this one there, it's really easy to see your R's, P's, equal signs, and constants are lined up. So this is ready to solve using substitution. Solve using elimination. I apologize. Okay, so if you notice, these have matching coefficients, so they're ready to add or subtract. You just have to decide which one you're going to do. Solve for P, plug that back in, and solve for R. Okay, next we have problem number 10. It's pretty similar to number 9, but we'll talk about it quickly. So a student has some $1 and $5 bills in his wallet. He has a total of 16 bills that are worth $52. How many of each type of bill does he have? So money, we've got $1, $5, and $52, and then we're talking about bills. So we have 2 different types of bills, and we know 16 total bills. So define your variables. I'm going to say D represents $1 bills, and I'm going to say that F represents $5 bills. Okay? And then if we add up the number of dollar bills and $5 bills, we should have 16 total. And then we know that each dollar bill is worth 1 and each $5 bill is worth 5, and our total amount is $52. So there you have another system set up, ready to use elimination. Very, very similar to number 9. Okay, now here's number 11. And if I'm being honest, when I first looked at number 11, I did not know what to do. I was really confused, and it didn't make a lot of sense to me. So if you read through number 11 and it doesn't make any sense to you, you're not alone. And actually, I used one of the question helps to help me solve this and see really how it wanted it set up. So the important information we need, Matt and Anna Killian are frequent flyers on Fast and Go Airlines. They often fly between 2 cities that are a distance of 1,575 miles apart. That's going to be important. On one particular trip, they flew into the wind, and the trip took 4.5 hours. So into the wind. That means it's going to be more difficult to fly. The return trip with the wind behind them, so this time the wind was behind them, and it's going to be quicker, it only took 3.5 hours. And then we need the speed of the wind and the speed of the plane still in the air still. Okay, so I've got a little more room, so I'll do this one right on the paper. So X is, let's say that's the speed of the plane. And let's say Y is the speed of the wind. Okay? And what you need to remember is the equation distance equals rate times time. Okay? So we're going to use the different pieces in our variables to set this up. And this is going to look different than what we've been doing at first. Okay? So the distance we're talking about is 1,575. All right? The rate is going to be the speed of the plane minus the speed of the wind. Okay, this is for one trip. This is our first trip that took longer. and our time is 4.5 hours. Okay, I don't need the H there, but just 4.5. The other trip, the distance was still 1575, but this time our rate is X plus Y because the wind was helping them. Okay, so they went quicker, and our time was 3.5. Now, we've almost got a system set up, but what we need to do is simplify this a little bit. So I'm going to take this equation over here, 1575 equals the quantity X minus Y times 4.5. All right, to simplify this, I'm going to divide both sides by 4.5 because I don't need that. I just need this X and Y. So when I do that, I'm left with 350. So that's my new equation, one of my new equations. All right, I'm going to do the same thing with this one. So 1575 equals the quantity X plus Y times 3.5. I'm going to divide both sides by 3.5, and I'm going to get 450. So 450 equals X plus Y. All right, now I'm going to use these two equations to make a new system. So I have X minus Y equals 350, and I have X plus Y equals 450. Now, that's the system that I'm going to use to solve. So it's already ready for me to add or subtract. So you should be able to add, cancel out your Y, solve for X, plug something back in and solve for Y. But this is the system that you're going to end up with. So on your problem like this on your own, you're just going to replace some different numbers here, and you're still going to do the same little process to get your system. And then once you actually get the system, it's pretty easy from there. Okay, number 12, the use of the functions below. Use the functions below to solve the problem. CX represents the cost in dollars of X units of a product, and R of X represents the revenue in dollars from sale of X units. Find the number of units that must be produced and sold in order to break even. So break even means that what you spend and what you earn are equal. They're the same. Okay, you're not making a profit and you're not losing money. You're just breaking even. So what you're going to do is you need to set C of X and R of X equal to each other. Okay, and so that's the same as saying 60,000 plus 30X equals 36X. So from there, you're just going to solve that equation. So get your X's together on one side, divide, and see what you get. And so whatever you get for X is your final answer there. All right, and then last, number 13, 1 Taco Supreme and 2 pan pizzas provide 2,800 calories. 2 Taco Supremes and 1 pan pizza provide 2,780 calories. Find the caloric content of each item. So we need to think about what we're talking about here. We've got Taco Supreme and pan pizzas. So I'm going to say that T represents tacos and P represents pizzas. Okay, and our first equation, if we have 1 Taco Supreme and 2 pan pizzas, it's 2,800 calories. Okay. All right, our next sentence, we have 2 Taco Supremes and 1 pan pizza. So that's 2 tacos plus 1 pan pizza, and that equals 2,780 calories. All right, so you want to find the caloric content of each item. So here's your system. It's set up. Now, you don't have matching coefficients, so you're going to need to multiply one of your equations by something and get your new equation and solve from there. Or if you're not sure, you can always crisscross those coefficients and multiply both equations. But either one of those should work, okay? Now, again, I know that I didn't work out these problems for you all the way, but I did help you get the system set up. If you can get the system set up, you should be able to do the math, because that's what we've been practicing the past few days. And you can always look back at your substitution and elimination notes, videos, whatever, or hit the Ask My Instructor button if you have a specific question about one of the problems, and I would be happy to help you. Have a great day.